Hello. Imagine we are diving into the world of deep learning, a fascinating subfield of machine learning. Picture a vast universe of techniques, all with one ultimate mission: to extract hidden gems of knowledge from data. Now, data could be anything from simple numbers like stock prices, masses of planets, or the heights of people at a fair, to sounds, pictures, words, behaviors, and preferences. Basically anything that can be expressed numerically. So, what's our quest in this data adventure? To find meaningful patterns and insights that can help us comprehend the data, or even predict future events. For instance, we might want to guess which movie someone would enjoy based on the previous ratings, decipher handwritten note, or identify a tune from just a few musical notes. The grand plan usually unfolds in 3 steps: pinpoint the information we want to extract, gather relevant data, and then unleash algorithms to retrieve as much of the data as possible. In this journey, we'll explore some major milestones in machine learning, like expert system, supervised learning, unsupervised learning, and reinforcement learning, ultimately landing on the intriguing topic of deep learning. Before deep learning was widely practical, expert systems were quite popular. These are like computerized replicas of human experts, doctors, engineers, musicians, all condensed into algorithms. The plan was to closely observe these experts, capture their thought process, and encode it into rules so that computers could mimic their expertise. But building and maintaining expert systems can be a challenge. Why? Well, because generating those rules, a process known as feature engineering, demands loads of human creativity and intervention. That's where deep learning swoops in like a superhero, automating the rule creation process. To understand expert systems predicament, let's use an example: teaching a computer to recognize the number 7. By observing and asking people, we might craft a set of 3 simple rules to identify a 7 from other digits. So the first rule, let's write a 7 here. Okay, here's a 7, just 7, simple 7. And the first rule: 7s have mostly horizontal line near the top of the figure. So let's draw them. No. Okay. First rule. Here's the top horizontal line, and the rest of the 7 I will use the other color. Okay. What is the second rule? The second rule, they have a mostly northeast southwest diagonal line. Okay, let's do that. Second rule. Okay, and another color for the diagonal line. And the third rule, those 2 lines meet in the upper right. So they have to meet. Oh, that's the rule. Okay. Let's use the point. Okay, so here's the 3 simple rules that computers are gonna use to find a 7 picture. But our set of rules does not see this, for example, as a 7. What color to use? Because we didn't realize, people sometimes add a bar to the diagonal stroke. We have to account for that too, huh? You see, when building an expert system, this happens again and again. With complex problems, finding the perfect rule set feels nearly impossible. We are constantly translating human expertise into detailed instructions, uncovering hidden thought processes, tweaking rules, and fixing contradictions in an endless dance with a massive, intricate rule set. Imagine trying to figure out a bunch of rules for a job, like capturing a radiologist's thoughts as they analyze MRI images, or how someone navigates hectic air traffic. It's challenging because the rules are often implicit and full of exceptions. Plus, with ever-changing technology, laws, and social conventions, it's never-ending game of catch-up. So our mission is to unearth meaningful information, and it's up to us to define meaningful. Usually we are searching for patterns that help us understand data or predict future events, like guessing a person's movie preferences, deciphering a handwritten note, or recognizing a song from just a few notes. So how do we find this information? Well, we follow 3 steps. Identify the information we want, collect data that might hold that information, and then design and run algorithms to extract it.